All right, so in this video, we're going to learn how to actually figure out an equation, a quadratic equation, given a set of data. So here's your set of data, and we're going to use Desmos. So if you haven't already done so, open up a Desmos so you can follow along and do this with me. And then we'll talk about kind of what you do. So now you're going to open up Desmos. So here's my Desmos calculator. And the first thing that my direction said, so this first thing the direction says is step 1, type the data into Desmos. So we're going to go through and we're going to type that data into Desmos. So here's Desmos. I'm going to make this so you can see just a little bit better. So here's your Desmos. Now you're going to type this in. And in order to type your data, you're going to go to that little plus sign right here. So you're going to add a plus, and then you're going to select table. And now you're going to type in that data. And so that data is 0, 2, 2.6. This is right here off of your example, your notes. 3.4 and 4.4, or 4.2, excuse me. Oops, it's a 3.4, not a 34. So then the next piece is now we're going to enter in our y data. So this is 10, this is 76, 71, 46, and 0.8. Now you can't really see your data, so we're going to go over to our little wrench here, and it says graph settings when I set that, and I look at this. So when I looked at my data, I went from 0 to 4.2. So my x values, I'm just going to put a little, like 0 to like 5. And steps means that's what I'm counting by, so we're just going to count by ones. And then my y values went from like 10 to 0.8 and all the way up to 76 was your high. So, and I don't know if that's totally my high, but we're talking about the height of a pumpkin being chucked because this is pumpkin chucking for catapult. So yeah, I'm going to hit the ground at 0 because that's your height. And then let's just say that this is 100. So now when I look at this, I can kind of look at my data, and yeah, that could probably be a pumpkin being thrown into the air. So now I want to get that equation to kind of represent that. So in order to make my equation, I go to the second one. So now I'm on step 2 in my data, and it says to go to y1. And you have to type a 1. So you have to type a 1 because this is your y1. And then you're going to type in x1 because this is your data in x2. Now, if you have multiple tables, you change it to be y2, x2, or so forth. But we only have one table. So now I got y things. This 5 elements here just means that there's 5 things in that list. So now I have to do the little tilty. And in order to find the little tilty, you can go here to your keypad, and then you can go to ABC, and you can see the little tilty right there. Okay. Or you can look on your keyboard, and right above the tab button is that little tilty. It's in between escape and a tab, and you'll have to go shift that little button. But so it's either one. Then you're going to go A, X1, and now you're going to square it. So I just hit squared. And then you arrow over plus BX1. You have to have the 1 or it won't work. And then plus C. So now this says that, hey, I've done this quadratic equation. So this is my quadratic equation, and you can see that it's actually graphed. So now this says that, hey, that negative 16, and then B is 65, and 9 is 9.998. So if I want this equation, if I write it, y to negative 16x squared, because negative 16.012, that's pretty negative 16. And then we're thinking about a pumpkin is chucked out of a catapult. So you've got that half a gravitational pull. So that should be negative 16 plus 65. That's your initial velocity. And then plus, and that 0.99, that's about 10. so it's probably like 10 feet off the ground. So this would be that pumpkin that's chucked off the ground. It was 10 feet off the ground when the catapult, the cannon went off, and that's a mighty powerful cannon at 65 feet per second. And so this would be your information. So the next part, it says, okay, so the next part of my question, so the next part of this, so this next part, it says, okay, find the data, find the equation. So we found the equation. Then it says, okay, what's the initial velocity? What's the initial height? When does the pumpkin reach that maximum height? How long is the pumpkin in flight? So what I like to do on all of these is just sketch it. And we found that our equation, h of t, is negative 16t squared plus 65t plus 10. And that's like pretty much real life. So we found this part right here at 10 is your initial height. So it asks, hey, what's the initial height? So initial height is equal to 10. Initial velocity is 65 feet per second. So this was 10 feet. And then where does it meet that particular maximum height? And the only way that you can get this is by going back to your Desmos and looking at that. So where does it meet? I just look and I'm going to say, oh, okay. So this looks to be about right here. That looks to be about 2.2 and 76. So 276 would be that max height. So then we go back. So this looked to be about, and this, you're only going to have to just approximate it. You could go through and find it, but this one is, I'm only asking you to approximate using your graph. That's totally fine. And then it asks you to find those zeros. So the next question is asking, what are those zeros? So this zero, looks to be about 4.2. So maybe you want this. I'm going to turn these off because I'm going to leave them in there, but I'm just going to turn them off because then I can kind of have my data a little bit. And now I'm going to look. So there at 4.211 is your zero. And then this zero over here is negative 1.48. So at 4.211, I have a zero. So I put that on my graph. And then my other one is at negative 4.8. So I put this into my data. It was negative 148 is the zero. There's a decimal there. And then 4.211 is a zero. So that's your estimated. So basically, how long was the pumpkin in flight? When you're looking at this, how long was that pumpkin in flight? Well, it started out and it went up, 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 and then it flew and then it hit the ground. Well, obviously in our graph, it continues on forever, but this is your it stops. So it was in flight. So the answer to that, the pumpkin was in flight for 4.211 seconds. Oops, you can't see that, sorry. So the pumpkin was in flight for 4.211 seconds. And then that's all you're going to do on your assignment today, which is just attached on this.